Hey guys, it's Nico. Welcome back. This is part two of Logics and Frames with Project Red. Um, Before we move on to the whole and the multi-frame um, cascading system, I wanted to clarify something. Um, Again, back to the motors. This being the correct way of the bottom one going up and the top one going down versus the logical up going up and down going down. Um, I just wanted to explain it a little bit better than I think I did. So these systems are equal in what they can do. They both can go up um, one, two more. This can, oh, let's see, one, two. So they have the same range. Um, they don't have the same total range, but they have the same movement range. These both moved up 2 blocks, where you can add to this too to make it also. But this is more efficient, is what I'm trying to get at. Um, this moved up 2 without detracking. This moved up 2, but to stop it from detracking, you needed 2 more frames up top and a block to catch it. Where it also needs 2 more blocks up, 2 more frames on this side and a block to catch it to keep it from detracking this side. So this incorrect system takes a total of 4 more frames plus another block, which is just inefficient. It takes more CPU usage, um, more TPS, uh, anything that's connected to these. So use this, don't use that. Also, I mentioned that you can use the wires and all that with the frames inside it, but also remember you can use it with pipes. So an example would be you have fluid coming in here and now it's going out there, where now it'll be going out here. Granted, there's better ways to do that with real, buildcraft stuff, but this could be useful for frame stuff. Um, and I'm gonna show you that in another video. That'll be my next video. I have a pretty neat idea for that. Now to the hull. Um, Before we get on to how this all works, I want to explain the counter system, the input to timed pulse system, which is what we used on that first door, which looked like this. It was the state cell, which had the input on the bottom, and it goes, well, in this particular, looking at it on the wall, it's on the bottom. It goes in here, it activates for however much time you have set. In this example, we have a 7 seconds, so it's going to run for 7 seconds. At the end of the 7 seconds, it went up and it activated this torch here, which we're not using in this example. Deactivates this for a whole 7 seconds, which allows this timer to run for 7 seconds, giving us 7 times 1 would be 7 outputs, which in this example right now, it's just going into a counter. That's to keep our count, just to show you that it ran for the 7. Right now it's a 0. This here is a different counting method I use. This I use for large projects. This is for, a single door, and this is I use multiples of these. One, it allows me to have the inputs, left or right, depending on how I have it set up. Um, Also, it's a little bit smaller of a footprint, um, and I just generally like this better for uh, large projects. But in this example, we're using a counter, which we used in the combination lock before. However, we're using this a little bit different. Instead of using the plus side to input, we are actually going to use the decrement side to output. And how we do that is we give it its maximum, and we're going to preload it with its maximum. we're also going to make sure the decrement is going to be subtracting the maximum. And when I say preload, basically we're going to let it, the timer run before it activates a frame. So when you first place it down, it will, here actually I'll just show you. So the timer runs once you place it down. We're going to place it on here. We want the decrement side. It's default to a 10, so as you can see it's counting up. We're going to switch this to 7, and then we're going to subtract it to give it its maximum. So now it's preloaded, and it will shut off this timer. So it is now ready for this particular example. So if we hit this button here, it's going to subtract. It's going to give it its decrement impulse. It's going to subtract 7, which goes to a 0. And at the same time, this torch, since it's met its maximum, it's going to deactivate and it's going to go this way. This will now unlock the timer, and the timer has 3 outputs, so it's actually going this way, and it's going back this way. So it's going to deactivate this, which this is set to 1 second, just like the other one. And so every 1 second it's given a pulse back into itself, which will give it a +1, and it's going to give, a pulse out here. So it's going to give 7 pulses in this way and 7 pulses up that way. So if I run this both at the same time, so this pulsed 7 and this pulsed 7. So they did the same thing. This is just a smaller footprint. It's easier to work with, and I don't need the state cell output on this. I don't need to use a NAND gate, so that's why. Also, I should mention that, sometimes you want the input to be on the right, sometimes you want the input to be on the left, so you can just, rearrange them. So this one is just, with the negative up top, and this is with the negative down here, and the loop goes back up top versus that. You can also do it like this here, which you say these both have the input on the right, and I'm just, controlling which goes up. The loop goes up or top, and you can do that by shift clicking on it, and that's not rotating it, that's actually changing it. That's rotating, and this is physically changing the input or the which side is which. Another thing I want to note is on the counters, this minus, I said it is referring to this side. It's actually referring to both of these sides, but just remember that the minus on this side is referring to this one up here and this one down here. So if the uncount is met, it's this side, or, if it's subtracted all the way to 0, it's going to be this side, and this is the decrement input, and then the plus side is going to be this side here. So this does the increments, and this does the if the maximum is met. So if it's a 0, it's this torch. If the maximum is met, it's this torch here. Okay, so I've explained the counter systems. I guess I should show you where this starts. We're actually using another mod that is made by the same guy, and he works on, I think, Forge and, Forge microblocks and all that stuff. This is the remote, and if you hold down shift and click on it, you can change its frequency. For the most part, I highly recommend not using wireless, especially on a server. If you're not on a server, it doesn't matter. But a server, they have wireless jammers. Well, there's wireless jammers, there's a sniffer, so you can actually find out other people's stuff, and people can just interfere with your wireless. There's also a tracking device, so you can like throw this on somebody and track them back to their base. So wireless, I mean, you can use it. You can set privacy with one of these. I can't remember which one it is. I haven't used it in forever, but you like this is to track, by the way. Um, anyhow, so don't don't use wireless on the server. I would avoid it as much as possible. So whenever I press this remote, it actually goes here, and it's gonna go both directions. This is a toggle latch setup because I have it going up and down for the same button, and here is AND gates that feed into the toggle. So this will only work if the toggle latch is active, which right now we can see that this blue signal cannot be activated. Uh, this gray signal can be activated, which controls the opening of the frames. Um, so the gray signal is where this will lead right now. So we're going to find a gray signal, and we'll come back to these in a little bit. So the gray signal. Actually, before we get back to that, we'll remember the gray symbol. So looking at this particular setup will work on this server or this mod pack because water regen, is the thing. You have two water blocks with an empty water block next to them. They will, recreate water. Um, some servers this wouldn't work on, or some mod packs, excuse me, this wouldn't work on because water doesn't regenerate. There is ways to still cover stuff with water, and that will be my next video. That has to do with frames moving pipes and other stuff. So when you first do this, when you first look at this, there's actually the outer frame that goes up, and then the inner frame goes, up to clear the water. And that's the only reason that one has to go up, is to clear the water. But we have to leave this outer frame, up to keep the water from spilling in. It's basically what that's for. So we have this is one frame set. This whole outer piece is one frame set, and then it's got this here, which is attached to the motors, which, by the way, are set incorrectly, but that was done for a reason. And it has this frame column set to it, and this is one of the most important techniques with using frames. This is giving me location data. So right now, this is a NAND gate that always runs. It's connected to a panel, and this is a wire. It's an alloy wire and an alloy framed wire. So this alloy framed wire always has a lit signal, and with this frame being up, it is giving the brown a solid signal. So basically, brown means that the frame is in the up location. And then once I deactivate it, by the way, why this is going, this is moving in two separate chunks versus when it opens, it does into four separate, that's because for some reason when they all come together at the center point, and they all connect, it causes some kind of render error and it crashes Minecraft. But back to this. So this is always solid, and now that the frames have moved, the brown is no longer active and the orange is active. So this is a way to locate where your frames are at. I now know that this has completed its task, and it's giving me an orange signal because this is the last thing that'll happen. So I now know that this is the last step in the chain, and it's ready to move on for, the next purposes. So that is an important step. The frame, let me open it again. The frames go up. So see, now the orange is deactivated and brown has begun its step. But this is important for a cascading effect. So now that this has gone up, this is giving me a brown, which gives another thing a set of instructions to do. And it's, a location. So like I was saying, this is one set, the outer frame with 2 columns. This, not here, but this here is one set of the 4 frames that are in the middle. And this set can actually move in 2 directions or multiple directions, being this way, and up and down. So they each go forward, backwards, and up and down. I was going to say left and right, but that doesn't make sense. And they're all connected. So it's got this frame platform which holds the camo cover, and then it holds a column with another, row. So these motors move out this row to its set destination, and then that will align it with these motors, and these motors will move them up. So these motors move it up and down, move this frame set up and down, and this frame set up and down. And that's generally, how we're getting multiple directions. And it's done by steps. So let's go back to where we were, and we needed a gray signal. Oh, excuse me. We need a blue signal. Oh, I have it open now. Sorry. Let's get back to where we need a gray signal because we want it to be the start point of not seeing it. So we're going to be looking for a gray signal. And by the way, so now, where was I at? Now that this is back in place, this is giving us an orange signal, which shows up here, and it's activating this OR gate here. So it's just saying, and what that's doing is that's basically telling me that nothing is, running and it's completed its task, because this is the last step. This is the last step in one direction, and this is the last step in one direction. If the machine's running, neither one of these can be active, and I'll show that in a minute. But so now we need a gray signal. The gray signal actually goes over here, and this is a AND gate, meaning that it's blank and blank. So this is lit, meaning that the purple or orange, which are the conditions that say that it is in a completed state, meaning again that it's not running. So if purple and orange are lit, this won't work, So we get a signal, it's going to pass through here, and it's going to go into our first timer, which has a state of 1, and we're on the subtracting side. So it's going to subtract 1 from this, bringing that back up, deactivating this timer for 1 second, giving us an output of a white signal. The white signal feeds into the cable. Well, where does the white signal lead? It leads to this frame motor here going up, and it goes up, which is the outer rim, which starts the process. But that's all it's doing, is giving that. Well, the next step, once this frame goes up, it's going to deactivate this orange, and at the same time, it is now going to activate this brown here. And that's kind of the cascading effect that we're going for. So now brown's feeding back in here. And if we look down here, brown comes out here. Brown will then go to this, which is basically a similar setup to that top one. It's just giving us a 1 count pulse. And as you can see, it's actually going to do 2 things. It's going to go this direction into the pulse former, and it's going to do the timer. So it's going to activate light blue for 1 pulse. Light blue is here, and that's the inner frames, and all the inner frame sets have a light blue. So this whole middle section as one piece is going to go up. But remember, this here, if I can fit in that thing. So it's doing that, and it's going to turn, this is a solid signal. We don't want a solid signal, we want a pulse, and that's what the pulse former does. It turns a solid signal into a pulse. It's now going to pulse this here, red alley wire, which goes back through, and it activates another timer. Now remember that this is once it finishes, so that pulse has already gone through to the blue, so the blue should be done, and then it's going to activate this counter, which is a count of 4. It's going to subtract 4 from it, so it's going to reactivate that. That's going to give us a yellow. Well, what's the yellow do? The yellow is telling it to go down, so it's already gone up once to clear the water, and so now it has to go down 4 spots so it can align with these motors. And if you noticed, where was I at? I was here. If you noticed, so the yellow, that'll be done, and once that finishes, this is going to turn solid, turning off the timer, and it's going to activate another pulse. And this pulse is going to go here to this counter, which should be 7, and it is going to give us 7 pink signals. The pink signal is going to be the pulling in. So all of these frames are now going to go backwards. And once the pink signal, that's the last step basically in this chain. The one thing to note is that once this is complete, there's no more, this is my opening set. Everything from here is my opening set. Normally, I can do it a little bit different, but because of this error that is occurring whenever these all come together at once, I have to, this board's a little bit bigger, but we had to double up on a step, and I'll show that here in a second. But so once this has pulled into 7, well, now I have a NAND gate here that's always on, and it's going to feed into this here, and it's going to give us a purple signal, which is basically stating that it has finished its complete step, and it's at a non-motion state, basically. So I guess I'll go ahead and activate it to that. So the outer frame goes out, the inner frame goes up to clear the water. It's pulling back down. It's aligned with those motors, and it's going to pull these motors, or it's going to pull all of the frames are going to pull back into their relative positions. And you can't see it, but it is, for some reason, the shadows are, it has now lit this purple signal telling me here that it is now stopped so we can activate it, and I know the position of it. So this is a pulse former that's underneath that, by the way, because I don't want a solid signal. I just want the pulse to flip this um, button here, toggle latch. So now this direction works and this doesn't work. So now we're looking for a blue signal. If we press it, it's going to be blue. The blue will start here. And we got to do it in reverse. Unfortunately, again, due to the bug, where if all these frame sets meet in the middle at the same time, it just crashes. If I remove these two blocks, these two blocks, these two blocks, and these two blocks, it doesn't do it. It's a rendering issue. It's just a bug. So this is now going to subtract 7. This blue pulse will subtract 7, creating 7 green, cyan, which only 2 of these motors, I don't know which ones it is. Is it this one? No, that one's lime green. So it's going to be this set of motors and this set of motors have a cyan. So they are going to go out 7, and they're going to get in position here. This one and this one. So this one and this frame will move into position, and they're ready to go up, but we have to move the other ones in, which is going to be done once this timer has completed this maximum of 7. It will send another signal up into the pulse, which is going to activate the lime green portion, this is also 7. It's doing the same thing as the last, but it's a different frame set just because of the bug, which is 7 pulses in there. And once it's done, again, another pulse that leads to this counter, and this is the counter to reset it into position. And it's only got to go up 3 times this time versus 4, because the 4 it went up to clear the water. Well, now it's just got to go up 3 to make it flush, to make it, hidden, which is going back to the blue motor. So that's, 3 up. And this is just connecting everything back. So it will be done at that point, and it will be reset to be hidden. Also, I wanted to just point out that you can hide cables fairly well. So this cable goes up here, and this has got a cover on it. I just wanted to show you. And then these are just covers, and the frame comes, and this is my debugging panel. So if I hit, I think it is green, and these are remove these, but if I hit a teal, these are all gonna, this one came out, and this one came out. So this just, you have a debug panel whenever you work on something, just so you can see that, things are working. So these 2 come out, and then the next ones come out. I actually need to back this up. This is actually trying to back up everything, but everything shouldn't be able to back up only the ones that are out, because this motor can't interact with this one because they're not in position. So everything should be in position now, and the button should work again. Granted, I don't know if I flipped my toggle switch because of that. But anyhow, so that's how this works, and I hope that gives you a little bit of understanding, a little more understanding. One thing I should mention is the motors use a lot of power. It's more than I remember, but anyhow, the point I'm trying to get across is make sure you have a lot of battery and a lot of generation running, especially whenever you're testing, because you'll start, frames won't react or motors won't react, and it'll throw off your timing, and you'll be sitting there trying to figure out what happened. Well, they ran out of power or they couldn't get enough power at that particular moment, so it's gonna just throw everything off. Um, but take the counter system out of this, take the locations. Frame should have a the end point and the beginning point should always have a um, basically a signal on it so you know where they're at, and it'll keep it from getting out of order. This is where we're gonna quit, and I will make another video. I have another idea that I was gonna show, and then I'm gonna kind of dive more into some other locks in another video. But I hope this was helpful. Nico out. Hey guys, it's Nico. Welcome back. This is part 2 of Logics and Frames with Project Red. Before we move on to the